channel. So today we are solving September 10 questions, which is insert greatest common divisor in linked list. So basically we're just given a linked list, and then between two nodes, we want to add a new node in between them, which be the GCD of them. So if you never heard about GCD, it's the greatest common divisor. Means what is the divisor they have that is the highest. So let's say 18 can be divided by 1, 2, 3, 6, and 9. And 18 itself, 6 can be divided by 1, 2, 3, and 6. Oh, what if I just write it out? All right, we can just go to PowerPoint and then just write things down. So, all right. So what's something that can be divided? 18 can go. So it's 1, 2, 3, 6, 9, and 18. And then 6 will be 1, 2, 3, 6. So GCD is basically finding like the divisor and then find the greatest one of them. So this will be 6. All right, so for 10 will be 1, 2, 5, and 10. So between 6 and 10, the greatest one will actually be 2. And then between 10 and 3, it will probably be 1, because this will just be 1 and 3. So this is just a common greatest common divisor. This is the GCD part. And yeah, so let's see if I can just copy this image and then just make a new slide and put it here. All right, so in order to do this, I'll just start with the expansion, right? So we can just start using a pointer, a variable called current, and then we have a temp that pointing for current.next. So in this case, we can see that we wouldn't lost this information when we're trying to point to like a new node, let's say 6. And then we still have temp storing the start of current.next, so we can always point it back, right? So here we can do in Python you can use math.gcd and then just pass in 18 and 6, and then it will return you 6. So after you're getting the 6, you just want to set current.next to be pointing to a new least node of value 6, and then current.next, which is this one, right? This one is current.next. So then we set current.next to point back to equals to 10. And then you just move current to be where temp is, and then move temp to current.next. And then you do it over and over again. So in Python, this is actually pretty smart. You can just call math.gcd, but I'm not aware if Java has this thing. So if you have to write this by yourself, right? Maybe you want to write a function of GCD of A and B, right? So a recursive way of doing this is you can set if B is equals to 0. This is just studio code. And then you return A. Otherwise, oh, this is so bad. Otherwise, you return, okay, let's see if I can move this up. Okay. Otherwise, you return, because this is a recursive call, you just call GCD again to pass in B and the value A mod B. So if you're using Java instead, you can use this. This is why you probably should start trying to do coding interview or OA in Python, because it's just easier, have the libraries, unless the company specify that you need to use certain language. So it doesn't hurt to know that this is how you write a recursion helper method to do GCD. All right. So after putting this in, you get, since we talked about this will be, we're adding a 6 right here, we're adding a 2 right here, we're adding a 1 right here. So this should be how it looks like after it. And then you just return the head, right? The head is right here. All right, let's try to code this out. So we can start with setting current equals to head. Oops. And then setting temp to be current.next. So while temp, so why while temp? Because we want to know that we have a current.next. If we already reached the last one, which current is 3, then there's no point going on anymore, right? And then I like to make everything to be one single variable and then put that to somewhere else. So I like to do gcd equals to map.gcd current.value and temp.value. And then I set current.next equals to a list node, which is the new one we're creating, and then put gcd into it. Some people like to just put this math.gcd into here, but I just want to make it clear that what is this step and then what's the next step I can put it in, right? So at this point you can set current.next.next equals to temp. So it's pointing back to temp. And then you can either set current equals to current.next.next, or you can just set current equals to temp. And then you can set temp equals to current.next. At the end, we just have to return the head. Yep. So submit this. The runtime will just be of n again, because we just go through the current, like the head, the length of head once, even though we access things like each node twice, but it actually doesn't matter that much because the coefficient of 2 will be dropped on big N. And then we not using actually any additional space because we're just processing while we go, and then we just create new list node that need to be returned later on. Right, I hope you enjoy this video today, and I'll see you in the next video.